This is our math practice for velocity, which is on page 323. What I'm going to do for you today is not only the example that is in the red box, but also the first practice question so that I can show you exactly what we expect out of you for full credit on these problems. So the first question, or the sample in the red box, says metal stakes are sometimes placed in glaciers to help measure a glacier's movement. For several days in 1936, Alaska's Black Rapids Glacier surged as swiftly as 89 meters per day. Now we need to find the glacier's velocity in meters per second. So this isn't really a velocity question, it's a unit conversion question. Here's what we're given. We're given the velocity is 89 meters per day. And we're asked for the velocity in meters per second. So the way you do this is just like this is way back to chapter 1, where we start with here 89 meters per day. Now our meters is good, that's what we want to end up with, but we've got to get somehow from days to seconds, and we do that with unit conversion. So we're going to multiply by a series of fractions that are equal to 1 that are going to maneuver this so we get the right unit. So I'm going to start the first one here. The unit I want to get rid of is day, so I'm going to put days up here. And I know that there are 24 hours in one day. So that's the conversion I choose. I know there's 24 hours in one day. That fraction's equal to 1, and I'm allowed to multiply. That cancels out my days, and now I have meters per hour. Also not what I want, but I can do this again. I can multiply by 1 as many times as I want. So I set up my unit conversion. I've got to have hours on top because I want to cancel it out. Well, what do I know about an hour? Well, I know there's 60 minutes in 1 hour. So that's a fraction equal to 1. I can multiply by that and I can get rid of hours. All right, still not done, but at least I'm getting the time units smaller, if you see what I'm saying. I started with days, I got to hours, and now I'm to minutes. So I just have to do this one more time because I know that in 1 minute, there are 60 seconds, right? So that means my minute goes away, and I've got finally my seconds in the denominator. So when you put this all into your calculator, you get a really disappointing answer, but make sure you do this so that you know you're using your calculator correctly. 89 divided by 24, divided by 60, divided by 60. You can hit equals in between those, but you don't need to. Your calculator knows, and you'll get 0.00103 meters per second, and that's our answer. It's pretty, like I said, it's pretty unsatisfying, but glaciers don't move really fast, right? So we shouldn't be too worried about that. Now, if you want to convert that to scientific notation and say 1.03 times 10 to the negative third meters per second, that's absolutely fine. The last bit of this problem is that they are asking for velocity, which means we need to include a direction. So that's not part of our calculation, but we go back and we see, oh, the direction is down the valley. So my direction of my velocity is just down the valley. You don't have to have north, south, east, west, up, down for direction. It can be down the valley, totally fine. So that's the sample, and your homework is numbers 1 through 3. However, I don't think the sample really reflected what I want you to learn how to do. So I'm going to do number 1 for you as well. Now, here I want to show you, our step-by-step process that you need to follow for this to make sense. So the first thing, I'm going to read the problem. I'm not going to write anything down. I'm just going to read it. Number 1, find the velocity in meters per second of a swimmer who swims 110 meters towards the shore in 72 seconds, right? That's my problem. I haven't written anything down. Now, I know that this is a speed and a velocity, a distance, and a time problem, so I'm going to make my data table. Here's what my data table looks like. I've got all the variables that I know I'm going to use, D, V, and T, with an equal sign. Now I'm going to go back into my problem and see what I'm given, and I'm going to write that down, okay? So I look back at my problem, and it says, find the velocity in meters per second. Okay, so that's what I'm looking for. So I'm going to put a question mark here next to velocity. I don't know that. That's what I'm looking for. Of a swimmer who swims 110 meters, that's a distance. And if you can't tell from context, the unit will help you. So next to distance, I'm going to write 110 meters, always including the unit. Finishing off the sentence towards the shore in 72 seconds. That's a time. So I write, 72 seconds right here. Okay, this is our data table. If you don't, we want you to practice writing data tables. If you don't include data tables in your problems, you will not get full credit. Okay, and sometimes any credit. So there's our step 1, data table. All right, step 2, we're going to write down the proper formula. Well, it's pretty easy for this one, right? Velocity equals distance over time. Now, we'll go into, well, let's do it now. If I wanted to solve for distance, right, how would I do that? I'd multiply both sides of this equation by time, and I'd get d equals vt. And this is just distance equals rate times time that you've known for a long time. What if we ask for the time? Well, that's a little trickier, but if I start with this formula here and divide both sides by v, I get time equals distance over velocity. So here's the 3 formulas that you'll use. You don't need to write all of them down for this problem, right? When you're doing a problem, you only have to write down the formula that you're going to need. So this is it. Velocity equals distance over time. Again, if you don't write down the formula, you're not going to get full credit for the problem. All right, so this is step number 2. If your data table is step number 1. Then step number 3, we're going to actually substitute our values, or like I like to call it, plug and chug. So velocity equals, what's my displacement? Well, I don't have to think about that too much because I already wrote it down in the data table, 110 meters over. What time do I need? Well, I don't have to think about that either because I already wrote it down in the data table, 72 seconds. What the data table does for you is it allows you to not have to continually be staring back at the book to figure out what to put into your calculation. Because you've got the formula here, you come back and you look at your data table and you don't have to think because you've already done the thinking. Now you go to your calculator, 110 divided by 72 gives you 1.5. We still need a unit, but again, you don't have to think about that either because it's right here in your formula, meters per second. Right? Now, we do need a direction, so I'm going to scoot back and say toward the shore. Okay? So we're going to do a lot of math this semester, and we're going to focus on making a data table, writing the correct formula, and substituting. I can't promise that you'll like doing these problems anymore by the time we're done, but they will be less confusing. So that is the sample and number 1 from page 323, and you have a few more problems to do after this.